Hello everybody. My apologies for this for this disruption. I'm Sylvain Cordier. I'm a PhD candidate at the University of Sherbrooke, and I will tell you about regional environmental life cycle consequences of material substitution in the case of the increasing the use of food structures in non-residential buildings. So in the second slide, I will just present you, I will just give you some word about the context, the literature review, the methodology, and the results. So few words for the context. As part of a policy for the use of wood in construction to support the forestry and the construction industry, the government in Quebec provides a roadmap to increase the use of wood in the construction. So we see more and more buildings with more than 6 floors of that are built with solid wood structures. It can go up to 12, and in Quebec and in Canada, it already went until 18 floors. So with the increasing numbers of publication showing that, how can I say that the use of wood in construction may be an eco-friendly option. Decision maker may move to use it on a large scale. So moreover, making the decision for large scale use of wood in construction can have environmental consequences that extend beyond the boundaries of the building sector. So a better understanding of these consequences, including material substitution, can help in the decision making. So in the next slide, a few words about the literature review. The environmental impact of wood buildings, usually compared to other materials, they have been continuously studied using several individual buildings or one structure type. But because, how can I say? Yeah, it has been continuously studied by using a comparison between buildings or comparison between structures. But because there is an importance in the building design, this importance have an effect on carbon emission. Because the environmental benefit of some projects are not easy to extrapolate, there is a need to try to catch the variability of the structural product. In next slide. So also in the literature used to present substitution factors or displacement factors that are mainly greenhouse gas or CO2 or carbon displacement factor, which is the amount of carbon which is displaced per ton of wood that is used. So all these factors, they contain certain source of uncertainties from the LCA. And among those, there is the amount of the material product that is substituted, because it will also mainly depend on the type of material and also the type of the project that is substituted by wood, and also according to the building architecture. Before evaluating the environmental impact displacement, and because we cannot directly use those displacement factors that are in the literature review, that are in the literature. It is necessary to study the material substitution factor in terms of relative functional performance for better result interpretation. And finally, in the next slide, the literature used to focus on the climate change impact. So in the next slide, regarding the methodology, first we had to estimate the amount of wood that can be used in the non-residential structures. Just some word of this context. In Quebec, 90% of residential buildings are made of wood, so there is no there is no more market for wood in residential buildings, but there is a potential increase of wood in the non-residential structures. And then per amount of added wood in this market, in the next slide we have to estimate how much steel and concrete are substituted per ton of added wood in the structure. Steel and concrete because they are the main competitor of wood structures. And finally, in the next slide for the methodology, the EcoInvent 3.6 database helped to model the background LCI, and Impact 2002 Plus was used for the impact assessment. Some assumption for the main materials. In the scenario, for the wood, there are two reasons that imply the choice of cross-laminated timber. So first, it's this type of structural product allow the construction of high-rise building. And second, this type of product is one of the most impactful wood products compared to other wood options that we were able to model or to use with the EcoInvent database. Regarding steel, steel is both produced with primary resource and secondary resource. However, in consequential approach, the secondary steel is considered as a limited raw material because its production depends on the previous consumption of the steel in the previous life cycle. So secondary steel, because it depends on scrap, it is not that type of steel that can be avoided by the use of wood. And also this secondary steel, how can I say, it is fully used and with an increasing trend and an increasing demand and production in Canada and in the rest of the world. So if there is a use of wood in a building instead of secondary steel, so this secondary steel is not used in the building sector, so it is available for another sector that can use this secondary steel instead of primary steel. And for concrete, we assume that the concrete products belong to local market because due to a large volume of required material, it is important to limit the transportation distance in order to reduce environmental impact. So the market for this type of product, where there is a low value to weight ratio, so this type of product tend to be local. So in the next slide, for different non-residential case study in the literature, we were able to calculate how much steel and concrete have been displaced per amount of steel of wood that is added. So there were comparison between steel and concrete structures to wood structures. So we calculated how many steel and concrete disappeared and how many tons of wood was added. So this is a figure for steel. In the next slide, you have the figure for concrete. And then in the next slide, it gave this distribution for different substitution factors of steel and concrete. So we can see how many case study and how many tons of steel and concrete were both displaced per ton of wood which is added in the construction. So there is an order of magnitude between the displaced steel and concrete. It is a combining displacement of steel and concrete per ton of wood. So for the result, I will just use the average value and the extreme values to simplify the scenarios. So, and you can see that on average, for steel, there is on average 0.6 ton of steel that is displaced per ton of wood, and for concrete, on average it was 4.5 ton of concrete displaced per ton of wood. So less displacement for steel. So in the next slide, for three scenarios, the minimum, the average, and the maximum scenario. Next slide, please. There are three amounts of steel and concrete that are displaced. And in the next slide, for each amount, we also pay attention to use different type of steel and concrete in order to consider the growth interval, and because also environmental impact depend on the type of steel and concrete. So in the next slide, I just show the different values and the different type of steel and concrete that are used for the average scenario, which is the most probable, and for the extreme scenarios, which is to catch the growth range of environmental impact. So this is the result for climate change, where we can see that for steel, where there is a lowest material substitution, it shows the highest avoided impact. So with the dots that are in negative, say that the overall impact is displaced. So on the top of the x-axis, they are the different wood processes to make the wood structures. And under the x-axis, there is the impact, the avoided impact of steel and the avoided impact of concrete. So it was for climate change, and we can see that there is the same conclusion for climate change and for human health and the primary resources. But the conclusions are reverse for the ecosystem quality, mainly because of the harvest that take a lot of space area. And inside the ecosystem quality indicator, the space area was one of the most contributor to this endpoint indicator. And in the next slide, I show the range of impact with the minimum and the maximum scenario. So for the minimum scenario, we are just above the x-axis. And we also have the same trend in the next slide for the human health and the primary resource. So with this model, we try to catch the extent of impact shift in production according to the variability in building design and material grades. And to conclude in the next slide, so the model tried to present the extent of impact shift and strategies and policy that want to address the current climate emergency. They also have to pay attention to the ecosystem quality. And also for future work, in addition to material substitution, that it was only based on the structural function. We may tend to use an equilibrium model that would help to catch the influence of the economic aspect between steel, concrete, and wood. And also in this case study, the additional harvesting of wood that was dedicated to the non-residential structure, it represented less than 5% of the total harvesting. But in the case where the additional harvest is higher, we may have competition between the different wood product in the different sectors. So if we add for example, maybe the envelope in the wood building, perhaps the different wood product sectors will have to find a balance. So maybe a use of equilibrium model in this context. And finally, we just want to thank the financial support of Natural Science and Engineering Research Council of Canada and the industrial partner of the CSR. So thank you for your attention.